Welcome to week 13 for geometry. So this week we're going to be talking about section 7.1. So let's look at our learning objective and our essential question. So our learning objective is I can prove the exterior angle theorem and apply theorems to find the sum of the interior and exterior angles of a triangle and other polygons. So then our essential question is how do we do that, right? So how can you prove and apply theorems to find the sum of interior and exterior angles of a triangle and apply that then to other polygons? All right, so let's get started. So lesson 7.1, we're going to start with something called the triangle sum theorem. So I'm going to move this. We'll talk about it. Make sure that you're writing this down in your notes. All right, so the sum of the angle measures of a triangle is 180 degrees. Now, some of you might have known that before. Some of you may not. Again, this is very important. It's going to help us do what we're doing today. So applying this to interior and exterior angles of not just triangles, but other polygons as well. So the sum of the angle measures of a triangle is 180 degrees. Okay, so then to get us started, let's just take a look at this here. So notice I have a quadrilateral image off to the right. Notice how there's a dashed line here. Okay, so let's kind of read through this and then we'll talk about how we're going to be applying this. So to determine the sum of the interior angles for any polygon, you can use what you know about that triangle sum theorem above, okay, that the measures of the angles of your triangle is 180. By considering how many triangles there are in other polygons. Okay, so that's why we have this drawing here, and that's why we have that diagonal line. So dividing it into the number of triangles that we have. Okay, so for example, by drawing the diagonal from the vertex of a quadrilateral, doesn't matter which vertex, okay, so I just picked one, you can form what? What do you see there? Okay, two triangles, right? So since each triangle has an angle sum of, well, we have that right here, 180 degrees, then the quadrilateral must have an angle sum of, well, we would have 180 and 180. If we add those together, we get 360. Okay, so we can use what we know about triangles and then apply that to our other polygons. So quadrilateral, we would have 360 degrees. So let's continue this, and then we're going to see if we can find a pattern. So the next piece here, again, using this triangle sum theorem, or finding the sum of those interior angles. So I have a bunch of different polygons here. So we have our one triangle, right? We can't draw any diagonals because that is what we're trying to form here. The quadrilateral we just did. So the next one would be a pentagon, right? We have 5 vertices for a pentagon. If we pick one and we divide it into those triangles, what we're doing is we have to draw the diagonals from a single vertex. So I'm going to use this top one. So I would draw it here, right, and here, pardon the squiggly lines. How many triangles do we have there? There would be 3. Again, it needs to be from the same vertex. So the next one we have is a hexagon, right, 6 vertices. So if we pick a vertex, and again, we draw our diagonals in there, 1, 2, and 3 diagonals. Oops. There we go. So how many triangles do we see there? There are 4, right? Okay, let's keep it going. Hopefully you can kind of see a pattern already. So if we move to a heptagon, so a heptagon, right, we have 7 vertices there. So if I'm just going to use the top one, again, we're doing triangles. Okay, so how many triangles do we have? 5. Okay, and last one, let's look at an octagon. So we have an octagon here, looks like a stop sign, right? So we have 8 vertices. I'm just going to do this top left one. 1, 3, 5 diagonals. How many triangles are in there? 6. There we go. Okay, so if you think about the number of sides in comparison to the number of triangles, this is going to help us come up with our theorem. Okay, let's kind of put this into a chart. So we have the first 2 here. We have the triangle, right? 3 sides, 1 triangle, that's 180 degrees. So let's keep this going. We did the quadrilateral, right? That was 2 triangles. So we had then 2 times 180, which was 360. So our pentagon that we just did, the total sides, 5. How many triangles? 3. So if we do 3 times 180, that's going to give us a total of 540 degrees. All right, let's do a hexagon. That's 6 sides. There were 4 triangles. So we would have 4 times 180, 720. All right, decagon. Now we didn't sketch that decagon. Decagon has 10 sides. Can you keep the pattern going? It would have 8 triangles, right? 2 less. So we would have 8 times 180, okay? Which would be 14, 40. There we go. Okay, so now can we turn this into a theorem that we can use to help us find the interior angles and solve problems? So that's where we're going next. So do you see a pattern between the number of sides and the number of triangles? You notice each of these is -2, right? -2, and then we times that value by 180. So let's turn this then into a conjecture that we can use for any number of sides and n-gon. Okay, so this is what we call the polygon angle sum theorem. So this should look like what we've been discussing here with that pattern. Okay, so the sum of the measures of the interior angles of a convex polygon with n sides. So whatever number that is n minus 2 times 180. That's what we just discovered. So we can actually use this to help us find missing angle measures on the inside, depending on whatever polygon we have. So let's work through an example here. So I have pieces of the setup. We're going to kind of fill in the blanks and then answer it. All right, so determine the unknown interior angle measure of a convex octagon. So we're working with an octagon here, in which the measures of the 7 other angles, right? Because an octagon has 8 total angles, is a sum of 940. Okay, so we need to find the missing 8th measure. So the first thing we need to do is find the total interior angle measure of that octagon. Okay, so that means we have 8 total sides. So let's set up using our conjecture here. So we have the total sum of those interior angles. Remember, it's our n, so 8 minus 2 times 180, which means we have 6 times 180, and that's going to give us a total of 1080 degrees. So that's for the whole octagon. Now, in the problem, notice we have 7 of them. The sum of those is 940. So we know that we are missing the 8th angle measure though. So we're going to set up an equation. So that means we have 940 plus x is going to equal this total 1080. So now we're here. And now it's just simply solving this one-step equation for x. So how do we get x by itself? Well, we would subtract our 940. So there goes that, minus 940, and that's going to give us that 8th angle measure. Okay, so 1080 minus 940 is going to give us 140 degrees for that 8th angle. So our unknown angle measure is 140 degrees. So that's just one example. We're going to do another one. Okay, so let's move on to our next example. All right, so this one is going to get us ready for our summative this week, questions 3 and 4. All right, so determine the unknown angle measures in this pentagon. So notice we have our image there. We know this is a pentagon. There are 5 vertices. We also have some right angles in there, right? 3 of them. And we have 2 other interior angles. Those are both the measure x. So that's the goal. We need to find out what x is. Those are our unknown measures, right? Because we know the other 3 are 90 degrees. So the first thing we need is to find the total degrees for those interior angles for a pentagon. Now, we discussed this before. Okay, let's just set it up just to review using that theorem. So we have 5 minus 2, right, times 180. 180. So that's 3 times 180. The total for our pentagon is 540. And that should match what we wrote in our table before. So that's the total. So now we need to set up an equation. We know all 5 of those together will equal 540. All right, so let's write this out here. We have 2 angles that are measure x. So that would be 2x, right? Plus we have 3 90-degree angles. Now I'm just going to write it in this step as 3 times 90. You are welcome to write it as what that value is. That's fine. Equals 540. But let's do that next, right? So 3 times 90 is 270. So let's drop our 2x here. 270 equals 540. Okay. Remember, our goal is to get x by itself. So we need to subtract our 270 over. Okay, we have 2x left over on this side, and we actually get 270 when we subtract that. Okay, so our last step here is to divide by 2. Again, we need to get x by itself. So our x, which is what we're solving for, our unknown measure, we don't have to do anything else, is 135 degrees. And that's it for that problem. We don't have to plug x back in, right? There's nothing attached to it, so we are done. Good. All right, so that's just a little bit of practice relating to those interior angles of whatever polygon we're talking about. We're going to talk a little bit more about triangles now, both interior angles and exterior angles. Okay, so with our triangles, notice we have a diagram there off to the right. We have a couple key vocab words here. So an exterior angle, hopefully this makes sense to you, it's an angle formed on the outside of a polygon. So we're specifically going to be talking about exterior angles of triangles right now, but here you have an illustration. So it's an angle formed by one side of a polygon and the extension of the adjacent side. So if you extend this side of your triangle outward, it's this angle that's formed. Okay, then we have something called remote interior angles. So you have this in your diagram again. Okay, it's an interior angle that is not adjacent to the exterior angle. So that's why it is not including this one. That would be an adjacent angle. Okay, so it is just talking about the opposite angle measures. So with a triangle, we have 2 of them. So we have a theorem here. And if you think about it, think about the relationship between these 2 remote interior angles and the exterior angle. Okay, let's look. Hopefully this makes sense. Again, think about the properties, think about the total degrees in the triangle and why this works. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So if you add your 2 remote interior angles up, you will get the measure of your exterior angle, right? And it has to do with 180 degrees in that triangle. You have supplementary and a linear pair here. So using that math, those 2 pieces, your remote interior angles, the sum of those, and your exterior angle have to be equal. So we're going to use this then to help us find some missing measures. So let's go ahead and work through a few examples. Okay, so we have 2 sets here. This is getting us ready for questions 1 and 2 for this week. All right, so we are finding an angle measure for each of these. So let's look at the first one. We want the measure of angle B. Now notice we have our remote interior angles. That would be A, right, and B. And then we have our exterior, okay, which would be DCA right here. So we can use that relationship to help us find the goal here is the measure of angle B. So notice we have some variables. So we can add our remote interior angles together, and that sum has to be our exterior, our 145. So let's set up an equation. Okay, so we have 5z minus 2. Okay, so there's that angle B plus angle A, 2z, equals 145. Now, you don't have to have parentheses like I put in there. We're going to get rid of them. I was just putting that there just to show that we have one angle plus the other. Okay, so let's combine like terms on our left-hand side. So we have 5z, right, plus 2z. We would have 7z minus 2 equals 145. All right, so we have to get z first, right, before we can find the measure of angle B. So let's go ahead and add our 2 to the other side. So 7z drops down, and we have 147. Last step to get z, let's divide our 7 off. Okay, so if you go ahead and do that, our z is equal to, comes out nicely, right, 21. Okay, so that's the first piece. Remember, our goal is to solve for the measure of angle B. So the measure of angle B, scroll down here, we have to plug in our 21 in to solve. Back and do it at the top here. So B is right here, right? We have 5z. So we're going to do 5 times 21 minus 2. Okay, so 5 times 21 is 105 minus 2. So the measure of angle B is 103 degrees. There we go. Good. All right, so let's try another one here. Similar, right? So the goal here is to find the measure of PRS. So with this one, we're actually finding the exterior angle measure because that is our PRS. But we can use the same setup, right? So we have our two remote interior angles. One of them is 90, one of them is x plus 2. And then that sum is going to equal our 3x minus 8. So let's go ahead and set that up. Okay, so let's do our x plus 2 plus 90 equals our 3x minus 8. Okay, so we have to get our x's on the same side and our numbers on the other. So I'm going to, just to keep our x's positive, I'm going to bring this x to this side, so minus x. Okay, at the same time, let's go ahead and add our 8 over, so plus 8. Okay, so on the left-hand side, we have 2 plus 90, 92 plus 8 is 100, equals, we have 3x minus x, so we have 2 x's left. Good, so go ahead, divide your 2 off, divide your 2, and we get 50 for x. Now remember, that's not our end goal. We have to solve for the angle measure, PRS. So that's our exterior angle right here. Okay, so let's go ahead then and plug 50 in so that we can solve. Okay, so we have 3x minus 8, so we're going to do 3 times 50 minus 8. So 3 times 50, we get 150 minus 8. So we have 142 degrees, and that is the measure of our PRS. Good. All right, we have one more example using this theorem. Okay, so we have a different picture here. I'm getting you guys ready for your questions 1 and 2. So determine the measure of the indicated angle. So we want to find the measure of angle N, right? Measure of angle N there is part of our triangle MNP. So again, we have our 2 remote interior angles and we have our exterior angle right there. So let's go ahead and set up our equation. We're going to find the sum of our remote interior. So let's do that part first. We have 3x plus 7, right, plus 63, and that's going to equal our 5x plus 50. So this is similar to the last example that we did. We have to get our x's on one side, numbers on the other. So I'm actually going to just combine my 7 and my 63 first. There are different ways to do this, but let's just get that done first. So we have 3x plus 70, right, equals 5x here plus 50. Okay, so we have to get our x's on the same side and our numbers on the other. So I'm going to bring my 3x to the other side, again, just to keep my x quantity positive. And if you want to go ahead and subtract 50 at the same time, we can do that. So we're going to have 20 over here, and then 2x. Let's go ahead, divide our 2, divide our 2. So our x then is 10. Now remember, we're still solving for the measure of angle n, so we have to plug that 10 in for the x in that angle measure. So we have 3 times 10 plus 7, right? So 30 plus 7, the measure of angle n is going to be 37 degrees. Great. All right, so that is our last example. Just a couple reminders going into this week then. Okay, make sure, guys, that you're attending one of those live sessions. If you need some extra practice in Blackboard, you have some worksheets and book problems that you can also try to help you. And then when you are ready, you can go ahead and take that week 13 summative. All right, if you have any questions, make sure that you are reaching out, and I hope you have a wonderful week.